Okay, so for part C, it says it has one point of inflection. Find the x-coordinate of the point of inflection. Right, let's do that first. So, guys, in a paper 1, I would say get the first derivative, get the second derivative, make it equal to 0, find the x value at which the second derivative equals 0. Yes, but in a paper 2, you have a calculator, so you can actually sketch that second derivative. So, right, let's sketch the function first, because I think we're gonna need that for part D anyway. So we're gonna sketch this. We have 3x plus 2 over 4x squared minus 1. Okay. Now, can you see the point of inflection would be my first question, and I would say it's over here somewhere. Look, because a point of inflection is where it changes from concave down to concave up, or concave up to concave down. Now, this entire part here is concave up. This entire part here is concave down. This is all concave up. But this is concave down to concave up. So it's going to be around here somewhere. Anyway, what I'm going to do, now that I've sketched that function, is I'm going to sketch. I can literally press this button here and sketch the second derivative. I just type in f(1)x like this. And where this graph equals 0 is the answer. So I'm actually going to zoom in here, and I know it's down here. And he says there's only 1, so look at it there. That's it, where this equals 0. That's my answer. So let's do analyze graph. 0. This graph, I have to choose the graph, lower bound, upper bound, minus 1.5954, minus 1.5954, minus 1.5954. So that's the x-coordinate of the point of inflection. Done. That's it. I don't need to, but if you want to do it to 3 significant figures, 1.60. I don't need to show any more working. It's only 2 marks. There you go. Done. D. Sketch the graph of y equals f of x for -3 to 3, showing the values of any x-intercepts, the coordinates of any local maxima and local minima, and giving the equations of any asymptotes. Okay, so first and foremost, let's get a set of axes. Let's call this x, and we'll call this y. Now I have the graph here. Let's just get the zoom out again. Zoom. Let's try zoom fit. That's not a good zoom. Let's try zoom standard. Okay, not too bad. I think I might even get rid of this just because it's not useful. Now I know, guys, I know the 2 equations of the vertical asymptotes. They are x equals a half and x equals -1/2. I got that from the previous question, so I'm going to just draw these lines. X equals a half. This is x equals a half, and then similarly apart. Well, that's too far left. Let's go here. This is x equals -1/2. And you write in the equations, guys, on the graph. Okay, he says, so he wants the equations of the asymptotes. He wants local maxima and minima and the axis intercept. So let's go in here and look what's happening. So guys, there's an axis intercept here. There's none over here. And there's one here. So let's first find the okay, and by the way, guys, he wants to go from -3 to 3. So 1, 2, 3 here, and 1, 2, 3 there. And you don't want to go any further than what he's asked for. So that's -1/2. Okay, actually, now that he said -1/2, I want to bring this in a bit more. That's a half. That's a half. And let's just say this is, let's say that's 1. That's 1, 2, 3. And this is then 1, 1, 2, -3. All right, so the intercepts, let's find the x-intercepts. This is this 0 here. Note, guys, this is not the point of inflection, it's a different point. So that's minus 0.6666. That's actually minus 2/3. I'll write that in here. Minus 2/3, so that would actually be just somewhere here. Minus 2/3 there. And I need the y-intercept. So to get the y-intercept, guys, it's the best thing to do is use trace, graph trace, and then you just put when x is 0, so you just type in 0, and it gives me this point here, which is 0 minus 2. So the y-intercept, let's say that's 1, 2 is down here. That is -2. And the maxima and minima then is the last thing he wants. So let's do the minima first. Minimum. So there's one here. Well, no, there's nothing over there. There, so at -1.1076. I'll put that here. Hang on. So it's -1.1076 and -0.33806. Okay. Hang on. -1.1. So that'll be over here somewhere. And then -0.3. That, okay. This is slightly annoying. I'm going to move this here. You could even put an arrow, guys. There. This is my x-intercept. And then this point is -1.1, 0.3 here. That's my minima. Okay. Oh yeah, and I have one more key point, guys. This maximum here. So menu, analyze graph, maximum. Okay, he's finding me a maximum where I don't want it. It's a bit annoying. Let's do this. Menu, analyze graph, maximum here. So it's at -0.222 and -1.66. So that would be -0.22, 1.66 about, right, something about here. Now let me just put in these points. This maximum is, or this minimum is this is -1.1076, -1.1076, comma, -0.338, -0.338, and then this maximum is -0.226, -0.226, -1.66. Okay, I think that is everything I need. Now you can, if you want, guys, write out all the different features over here. But I think this is everything we need. And just be careful of the endpoints. So for -3, it's close to, well, it's pretty close to 0, but it's not 0. And for 3 here, it's, well, it's not that close to 0, but whatever. So I'm going to start here. He goes down there and turns. Hang on. Now note, guys, as I always say when I'm drawing graphs with this pen, you can do better. So that's your asymptote there. He comes up here. This is an asymptote there. This is your max. Something like this. And then this is an asymptote here. That's poor. Something like that. Now note, guys, I've stopped at -3. I've stopped at 3. I've put in my max. I've put in my y-intercept. I've put in my min. I've put in my x-intercept, and I've put in my two vertical asymptotes, and I've written the equations here as well. Okay, so that's it. That's obviously taken me quite a lot of time, but well, you get 5 marks for it. Ideally, you can do it in a quicker time than I did it there. Okay, I'll do part E in the next video.